we can use this toy to illustrate the three phases of matter. And here we have just a cascade of planes and metallic balls, and when we turn this over the way the toy works, the balls just go down the plane. But this is what a gas might look like if we were able to focus in on a very small parcel of it. These metal balls represent the gas molecules, and they're moving at very high speeds and bouncing into one another. And the spacing is about what you might see if you were actually looking at a gas. Now we can also look at what a liquid might look like by allowing the system to condense. So we go from this gas state and let all the metal balls roll down the plane to the bottom, and that simulates condensation. And then at the bottom we have this collection now of the metal balls, and that kind of spacing and condensation would sort of represent what a liquid might look like. And the cool thing about this little toy is that it actually simulates a little bit of vapor pressure. So occasionally a ball can escape the surface and then come back down into this liquid state. So that actually is a nice emulation of the liquid state and what vapor pressure might look like if we were able to look at it at the molecular level. And then we can further tilt this plane down to use gravity to further pack this system, and now you can see we're starting to get a regular geometric arrangement here of the atoms, and this would simulate then the solid state. So in the solid state we have a very close packing, and you can see occasional void there, a defect, which actually simulates a real solid. And in annealing you sort of shake this thing around, try to remove those defects, and that's done temperature annealing of solids to try to avoid cracks and holes and things of that nature. So again, in a solid, very, very tight packing, strong intermolecular interactions. As we go to a liquid state then, we have a little bit looser arrangement, and some of the molecules can actually escape the surface. And then finally the weakest interactions result in then this gas state, where there's large intermolecular spacing between the molecules, and they're moving over distances greater than their molecular diameter.